So right now we're going to talk about how we can quantify waves. So this example is going to be a hiker shouts toward a vertical cliff 685 meters away. The echo is heard 4.00 seconds later. There are three parts to this question. The first part is to determine the speed of sound of the hiker's voice in the air. The second is to use the wavelength of sound, which is 0.750 meters for this example, and use that to determine the frequency. And then finally, once the frequency is known, we can determine the period of the wave. So what I would recommend doing in problems like this is to start off by drawing a picture. So right here, I'm going to draw a hiker. At a time of 0 seconds, they shout. They shout at a vertical cliff. The distance from them to the cliff is 685 meters. The echo is heard 4 seconds later. That means that the sound wave had to have hit the wall and reflect back at the person. That means the total distance traveled, left and right, is 685 meters plus 685 meters. Because they hear it 4 seconds later, so 4 seconds overall has passed. Now speed. The speed of the wave is the distance traveled, 685 meters plus 685 meters, over the 4 seconds traveled. So plugging that into a calculator, the total distance traveled is 1,370 meters. And if that takes 4 seconds to occur, that means that the speed of sound in the air for this problem is 342.5. The units of speed are meters per second, which showed up in the numerator and denominator of my calculation there. So that's the speed of sound. We also know the wavelength of sound is 0.75 meters. To determine the frequency, we start off with our equation for wave speed. Wave speed is equal to wavelength times wave frequency. If I'm trying to solve for the frequency, I rearrange the equation to get the frequency by itself. Frequency is the wave speed divided by the wavelength. 342.5 meters each second, and the wave is 0.750 meters. So the wave speed divided by the wavelength is going to be 456.67. The meters cancel out, giving us units of 1 over seconds. That's also known as a hertz. There are 456.67 cycles every 1 second, or 456.67 waves each second, which is how many hertz there are. And then finally, period. Period is the inverse of the frequency. We just calculated the frequency, so we just take the inverse of it to determine what the period of time would be. That would be 0.0022, and then because it's 1 over seconds, that brings the seconds up to the top. So the speed of sound of the hiker's voice in the air, 342.5 meters per second. The frequency of this wave, if the wavelength is 0.750 meters, is 456.67 hertz. And then finally, the period of this wave is 0.0022 seconds.